In the following video, we're going to see the assembly and setting of a Creality CR10 3D Cartesian printer. It is 400 millimeters high in its Z-axis, 300 millimeters in its X-axis, and another 300 millimeters in its Y-axis, and it has a hotbed. The following video are a summary of both the machine setting and its assembly. Now, the video tutorials. Good afternoon. We're starting now to explain the assembly of a 3D Cartesian YZ printer. In our case, we have a Creality CR10. It is a big printer with a base where we will print off 300 millimeters wide, 400 millimeters high in its Z-axis. We're going to show all the parts it has, all its elements and items, and later we will see its assembly and how this printer works. We'll check the cables, revise everything is correct, and order a first print. First thing to check is the content of the box. It is a type of printer we get half assembled. A big part of it is fitted. These kind of printers do not need a long time of installation. So let's see the items we have and we will need for its assembly and installation. We will see now the content of each of the boxes. This first box contains a filament winding. It is of approximately 250 grams, PLA type, white and with a thickness of 1.75, which is one of the standard used in 3D printers. The other standardized one is 3 millimeters thick, which are most widely used in more industrial machines. There is no big difference between them both, though. One of the questions they make me most often is whether the machine to buy should use 3 millimeters or 1.75. I usually recommend 1.75 as most machines are for a non-super professional use, but mainly for small medium-sized companies, SMEs. And these machines do normally require 1.75. These are also cheaper than the 3 millimeters ones. One of the boxes then contains filament, and the other box we have here has all the necessary items to make the printer work. An international power cord, American or English one, and a European one. A different one for different parts of the world. We also have some clips in this bag, clips just to hold the cords so that they are not loose, they are fastened. This printer has a good finish regarding this anyway, so the clips are just a matter of a personal choice of holding the cords and wires as we please. We have as well an Allen key, a spanner to be used in the assembly of the two differentiated parts we have. This spanner will let us change, among other things, fix the nozzle, fix the bed screws if we consider they were a bit loose. We will check it later and we'll see we'll have to use the Allen key or the spanner. The other object we have in the bag are the widely used pliers. Almost all 3D printers provide them, small pliers. We'll see how useful it is. We also have trims, which are made of plastic and fixed to the printer's frames, and which will not affect at all the quality of the print. It is just to make it look better. This is a tube through which the filament will be inserted, and we will see it later, as this is a button approach. We will explain later what this is, as it is apart from the hot end where the filament gets hot and extrudes. This tube acts as a guide for the filament and prevents the filament to bend during its way to the hot end. There is one tube already installed in the machine, and this one we keep it just in case the other one gets damaged. A simple support to hold the filament. We will see now where it is, so that the filament coil can roll and work properly for the printing process. A scraper, which we must be very careful when using it. It is very easy to cut yourself. Many people round its corners, as these scraper's corners are really sharp, and its main use is to remove our print from the build plate if the object happens to be too fixed to it. Although we'll see some tricks and recommendations to try to avoid the use of the scraper. We'll find some important items of our machine that I would like to explain better later when we start the assembly of our printer, but just say they are limit switches. Limit switches or end stops make the machine know where to stop its movement, Z, Y or X axis. One of them is already fitted in the machine, and we have to assemble this other one we have here. I'm leaving it here. We'll need it later on. USB device with micro SD card to be used to storage the information of the files, and if we happen to need to use the printer's firmware, we will do it with the micro SD card. We also have different bolts and nuts, which are mostly spare parts. In this version of our machine that is constantly being updated, we are normally provided with some spare ones in case of loss. It happens the same with these two components, it's connectors, a connector and what we know as nozzle or extrusion strut. These also are spare items. The nozzle is already pre-assembled. This is a nozzle. This type of machine has normally one pre-assembled. This component makes the molten filament go through it to deposit it in successive layers. The spare one is usually 0.2 millimeters wide. The one already in the machine is normally 0.4. It is curious this brand does not point out this is 0.2, and well, it may cause difficulties. Now we are going to place the two main parts of our machine in the correct position. We are going to connect them with the tools we have in the box to form its structure. We will check afterwards all components are properly fitted and assembled. We'll start it and we'll try its engine, the movement of the engine. First thing we're going to do is to remove these clips that secure the upper part of the frame in order to obtain a proper movement of the threaded rods regarding the engine. I would like to point out among the most advanced 3D printers engines we have those manufactured by NEMA. It is a popular brand as their engines last really a very long time and they are very precise in each of the needed steps. We'll see later what we refer to as the steps of the engine. This brand is one of the most important ones in 3D printing NEMA. This is the Z-axis frame and X-axis at the same time. It is the one that will allow us the movement in X, a horizontal movement, and the Z-axis, which is a vertical movement. Together with the movement of the bed, Y, we will have the three axes of a Cartesian printer, which is the one we have here. To assemble the structure, we need the two main parts and the bolts the supplier gives us and the end stops. Limit switches we will have to fix so that the Z-axis is set as at the required height to avoid the nozzle through which the filament is extruded to get in touch with the hotbed, as it will damage it. We have then to fix properly each of the parts. The first step is to fit this structure. Second step will be to fit the end stops to the lower part of it. Finally, we will connect the wires. The wires go from the central processing unit to each of the engines. Some of the connectors are covered by a metal and plastic component. Those connectors which provide the main power to the power supply. We also have various connectors I will show you later that will connect the different parts of the engine of the main unit. These connectors we have here, and we will use at the end, provide the engines with the information, the power and also the end stop. That is, communicate the end stop so that when we click, the bed knows when to stop the movement of the engine. These cables will be connected at the very end. How do we have to install the frame? First, we need a large space. This table, for instance, is perfect. We must decide the correct position of both frames. In these cases, and almost in all Cartesian printers, the engine that pushes the bed must be at the back. So this will be the front part and this one the back side of this frame. The Bowden extruder and the Z-axis tool must also be at the back side regarding the viewer. In this case, the viewer is there. This frame is set this way with one of the bolts we have here in this back. They are screwed from below with the bolts, washers, and we make sure they are properly fastened. This structure should not move at all, as that will affect the quality of the printing. So now I'm getting the bolts we need. As you can see, they come in their own bag. We have 4 bolts to set both frames, and we also have more bolts that we will use to fit the structure that will stand the weight of the rod to the power supply. In this brand, it has to be fixed to the power supply. I'm getting the bolts we need now. I will show them now to the camera. We have 2 bolts. We will use the Allen key this brand provides us with, and washers. It is really easy. The difficulty is because it is a big piece and its manipulation is a bit difficult when we're trying to fit the whole structure. This is very easy, as we have the instructions for use of each of the wires of the power supply and the main board. Each connector has a plastic yellow label that specifies the axis it refers to. For example, we have here X-axis, this one states E for extruder, Z-axis, and so on. We must be very careful, and we should not bend the connectors, as we will have to change that item if we happen to damage any of them, and it is a bit delicate. This particular model is designed so that the central unit is connected regarding the viewer. If she is here at the front, the unit must be on the left. If we place it on the right, we will be forcing and straining the cables, their distance. In fact, we would not be able to place it like that. First thing we're going to do is to connect the 2 wires that will support the power supply of each of both parts. The main power supply is for the power of the hotbed. It will give the power only of the heat to the hotbed. This wire only function is to provide with heat the hotbed. This one here is exactly the same, but it heats the resistance of the hotend and at the same time the movement of 2 fans we have here. We're going to explain now the function of these two fans. We have a fan on the front, which is very important. This front fan dissipates the heat where the filament goes through. Not all of it has to be hot. If the whole hot end were hot, we would have obstruction problems. In fact, it is very common for low-quality hot ends to get stuck continuously due to the fact there is not, let's say, a proper limit between the areas that must be cooled and those that must be hot. The bigger the limit is, the better for the printing process. So which part must be hot and which one cold? The part with the resistance is the one that must be hot. This part will melt the plastic and is connected to the nozzle through which the plastic will be coming out. That's the only part that must be hot. We also have a heat dissipation. To be able to see it more clearly, we would have to dismantle this central item. We will see the heat dissipation item which avoids the plastic to melt before it has to. If the plastic melts before it should, a blockage will be formed and will stop the plastic by pushing it to go through where it has to. That item, depending on its quality and the material used for its ending, will need more or less extra cooling. This is why we have this fan. This fan cools even more the item in charge of avoiding the heat to go where it must not. It acts as a coating, as a barrier that separates the hot part from the part that must not be hot. We also have a layer cooling fan, very important as well. Why this name? Because when the plastic flows in a semi-liquid form or semi-solid, and depending on the kind of plastic we're using, it will harden after a few seconds or milliseconds. As for PLA, we need the plastic, due to its own characteristics, to start being cooled at the very moment it starts coming out. The reason for this is because PLA is a plastic that if we printed an object and we left it in direct sun, 50, 60 degrees or higher, this plastic begins to deform itself. Or you can think, well, where I live we do not reach 50, 60 degrees. But if we leave it in a place where the sun is shining on it all the time, and it is, for instance, inside a car, I can guarantee the objects will get deformed. If outside the car the temperature is around 40 degrees, in the inside, if the sun is hitting and shining on it, almost 60 degrees can be reached. The glasses of the car can create a greenhouse effect. PLA is a soft plastic when dealing with high temperatures, and it needs to be rapidly cooled at the very moment it comes out, so that it properly solidifies on the bed and layer by layer. This is why we have a layer cooling fan. When using ABS, we normally print with the layer cooling fan either off or at its 10%, at its minimum, and so on for each of the components. That fan must be directed only to the exact point where the filament comes out. If it is not directed to the exact place, we will have a printing problem that will be molten layers or incorrectly aligned layers. Once all this is explained and stated, this connector is only used to provide power to those fans and to the hot end resistance, we are proceeding to connect it. To see where the connectors go, at the back side we can see male plugs with their specific features to fit these socket connectors. In the case of the fans and the hot end, we must connect it in the upper side according to the notch here, and it is clearly shown. We screw it until the wire is securely fixed. First wire connected. We are working now with the wire that provides the power to the bed to heat it and make it a hot bed. It is the last one of the connectors, and we screw it. Once this is ready, we will conceal the cables later so that they are neat and do not tangle or twist. We can always connect and disconnect them to decide if we find appropriate they are on one side or another. For example, let's see an example of this. I can disconnect this wire without problem, easily. Now it is disconnected, we can put it behind this, for instance, because I find it easily this way, or because we consider it is better for the movement of the jeans. So we have no problem at all if we want to rearrange, disconnect these wires. On the other hand, the wire we are setting now are more delicate. These type of printers are designed not to be moved often from its place. We are proceeding now to connect these three elements, these three connectors. As we can see, and as we have a 3-axis Cartesian printer, we must find these three wires, one for each of the axes, one for Z-axis, one for X-axis, and one for Y-axis, and a longer one that supplies the power to the extruder engine. Once the setting of the end stop is finished of its Z-axis, we proceed to assemble smaller parts. In this case, we have this item in two parts, and it's the one in charge of supporting the filament. It is provided in two parts. We just join them using its washers, and we use the bolts we have in this bag. We have a spare one just in case we lose one. These bolts we can screw by hand. We do not need a screwdriver. They are used to connect the support of the filament. The filament coil will be placed here, and we will have to insert the filament in the extruder. We are going to fasten this part. The last item we have to set are the trims of our machine, CR10. I very usually advise when printing, I do not recommend using particle board tables with tubular legs, as it will vibrate due to the printer's movement, which produces a displacement of the layers and will lose quality in the prints. So the more stable the surface the printer is on, the better. There is no problem to test the machine in that kind of table, but if we want to have good results, the more stable the table is, the better results we will get. If we do not have a really stable place, we'd rather put it on the floor. I'm using another bolt. This seems not to work properly. Now, this one is better. Right, as we said before, we can do it by hand. We do not need a screwdriver or any other tool. To finish, and as we said before, the trims. We can place them where we want. It is not compulsory to use them. They are fitted all over the aluminum sections, and just to get a better look of our machine. We could place it here at the upper front, all the way to the other end, and cut it here using a knife or cutter. We could also use the pliers, but we don't really recommend to use them as they can make the plastic undulate, wave. We are doing it with the pliers as we have enough trim, but we strongly recommend to use a cutter. As you can see,
we have to do it very slowly, and it is not at all the best way to do it. Using a cutting blade, we will always get a much better result. We can place it all around our machine sections to make it look attractive, more glamorous. Once the assembly is finished, we will check the machine. In order to do it, we connect the power cord. This power cord connected to its backside, to the power supply, and main part, which is all here. We turn on the power switch and we will see if the display is on. In our case, we can see the name of the brand as well as the information on the screen. Most 3D printers, mostly of them, provides basic and functional information which consists in the following. It will show us the axis, usually in millimeters, the position of each of the axes. In this case, it states they are 000 as until we do not configure it a bit, until we do not see how the engines work. We won't be able to check whether each part is in its right place. Other information we have is, for instance, the bed and the nozzle's temperature. How does the machine calculate the temperature of the bed and the nozzle? It uses thermistors. It uses just a simple temperature sensor. It is a simple resistance encrypted in glass that, due to the heat dilatation to its expansion, makes two parts to be connected. It produces passage of current. This leads to the fact the machine is aware because of that dilatation or the absence of it. It can interpret the temperature of both parts, of both the bed and the resistance of the nozzle. The display also shows us it is 23 and 24 degrees. This is because it does not reach zero, and it doesn't reach zero. It points out a minimum figure of 23-24. If the room began to get warmer, or if the machine were in the sun, the temperature would increase. Right now, it shows both the nozzle and the bed as 0 degrees because the machine is not working yet. The layer cooling fan is also highlighted here to give us the information if it is working at 100% or if it is not working. Now it says it is a 1% speed, which is as if it were 0%. It also informs about the remaining length of the printing process. Usually it does so using percentages. We have a bar here which is empty right now and that will be filled with respect of our item, of the printing of our item. It will inform if it is at its 25%, 30, 35, 33, 34, and so on until our 3D model is finished. So this is the main information these types of machines provides us with. Another important issue of our central item and this display, among other things, is that we are able to manipulate certain aspects of our printer. In this case, one of those factors, and which is crucial, is to inform the printer to set the position of the whole system at 000 coordinates of this Cartesian print system.
We're going to see how to handle or how to manipulate the 3 axes by hand using the menu options. We click on Prepare, the first option again. We're inside and we go to the last of the options offered, which is Move Axis. It is in English already and it says Move Axis. If we click on that option, and as we said before, we will be able to move X, Y, and Z axis. We can select the amount of movement by selecting 10 millimeters, 1 millimeter. That is, we can select movement every 10 and 10 and 10 millimeters, every 1 millimeter, or also every 0.1 millimeters. In our case, and so we can see the process a bit faster, we are selecting the amount of movement every 10 millimeters, for instance in its y-axis, which is the one in charge of the bed. We click on the option Move Y. We can see that by using the wheel, we can order it to move forward. If we do, this happens because we have overdone it. As we don't have an end stop in the upper part, it tries to continue forcing the engine, which is not good, as you can see. If we wanted to go back to a local position or placement, to home position, we will have to go back to Menu, Prepare, and we'll select Outcome. One of the clips has been released. That sound you heard was one of the clips that became entangled with other of the clips that is holding the glass. There is no problem. So, that is the movement of the bed. It is good to check all the engines. Let's revise all the engines. We are checking now X-axis, which is the one that stands the hot end. For this, we have to go again to Prepare option, Move Axis. Now we are selecting a 1 millimeter movement to see another possibility, and we select the option to move the X-axis. Move X. We can see, as I'm rotating the wheel, we can move the X-axis farther or closer. Last one is the Z-axis, the vertical axis. We can see the axis works properly. They all work properly. I can order it to go upwards in this case. In fact, I'm ordering it to go up, as the next step is inserting the filament in order to do a printing test. This is always the last step before checking the position of the bed. When we refer to the position of the bed, we mean the height the bed must have together with the nozzle, the distance of the bed regarding the nozzle tip, about the home, and all the main parts of the bed. What do we mean by the main parts? The four corners and the center of the bed. This is very important because otherwise our filament will not fix on the bed surface. There is an exact measurement. We usually say exact, accurate, but we can really manipulate it by hand or roughly. An accurate distance, accurate as explained before, so that we get the best placement and position to make the filament fix to the bed or to its surface. That distance is 0.1 millimeters between the surface of the bed and the nozzle. That is the distance the whole system must use in order to print properly a PLA, ABS or nylon model. Why are we saying it is more or less precise? Why don't we leave that option completely confirmed? We sometimes see that distance of 0.1 millimeters is not enough depending on the filament. Due to the bra we are using, the quality of the filament itself, if it is a bad or of a worse quality, we should reduce it or separate it a bit, due, as we just said, to certain circumstances. Quality of the filament, room temperature, the use our system has had, if it has been widely used and the nozzle is a bit overused. So with the time and its use, we will be learning to decide whether that 0.1 is the appropriate measurement or not. This is why we're going to calibrate the bed. And how do we calibrate the bed? First of all, we need two main things. First, move everything to 0, 0, 0 axis. That is, we have to go Home. This is regarding the menu. Home. First thing is ordering 000. Right. Second thing we have to do is to unblock the engines. Why? Because I need to unblock x-axis and y-axis engines to be able to define properly both the 4 points and the center of the bed. We select again Prepare, Disable, Stipper. The engines have been turned off, and so we can move by hand both the y and x axis. We could also move the z axis, but we shouldn't now because, as we said before, there must be a distance of 0.1 millimeters between the hotbed, the bed itself, and the end, the tip of the nozzle. We are now inserting the filament in the extruder. Once it is inserted, we have already cut it beveled, and it has really helped us to insert it in the feeder and the tube. We press the clip and we push the filament to enter, as we have to go through the whole length of the tube until we reach the nozzle. We are elevating a bit the z-axis so that you can see how the filament comes out if we keep pushing it and it reaches the hot area. I put the z-axis up and not the x-axis. We want to move the z-axis, okay, now. We are elevating it a bit more so that we're able to see how the filament comes out through the nozzle. The thickness of the filament, if the nozzle is 0.4 wide, must be obviously 0.4. Is this exact? Completely exact? Very, very indeed. We're going to revise now whether the filament is properly charged and goes through the hot area. In order to do so, we have elevated a bit more the z-axis so that you can see it better, and we push the filament so that it goes all through and get to the hot area. Once it reaches the hot area, we will see filament coming out the nozzle. We will very probably see the filament coming out in a different color, although it is white. The companies make different tests. We see now it's coming out and it is orange. We keep pushing. We are doing all these by hand, but we can also set in the display screen and order it to extrude a certain quality of filament. We can see the filament is coming out. When we see it comes out completely white, then we can stop pushing. Okay, so let's continue. We are proceeding now to insert the card in the central unit of our 3D printer in order to load a file that mostly all printers provide as an example. This one is provided with a USB adapter so that we can insert the card in a PC, Mac, a laptop, and so be able to load the files we would like to print. In this case, as we are going to use the sample file, and so we insert the card in the main unit. The card has to be inserted in its groove placed on one of the sides. It is very important, especially when using this manufacturer, to insert the card upside down. That means the connectors have to face the ceiling. We insert the card until we hear a click. Once the card is inserted, we have to set the system so that it reads it. In order to do that, we go again to the options of the menu, but now in the main options we can see at the bottom an option named Edit SD Card, which means initializing or start reading the SD card. We select it, and it has already loaded the card, or at least it has already begun to read it, and we select the option right above this one, which is Print from SD. We select that option and we can see different files, different folders. We want the one named test dog G-code. This test dog is a little dog, a toy, in G-code format. G-code format are the files 3D printers read. It is the one that contains each of the coordinates for each of the layers regarding the genes. So we are loading that file. We select print, and now the file gives the machine a series of instructions as follows. It states the nozzle temperature it must have, the temperature of the bed, and where to start printing the object. Right in the middle, be on the left, on the right, as well as the coordinates for each of the layers due to a layer software we will see later on. Let's check if the bed has been properly calibrated so that the first layer adheres. This file needs 1 hour, 1 hour and a half, or 2 hours to be done. So we really need the first layers to stay properly fixed, as it is a long process. In order to do so, I'm trying to move the machine a bit so that it faces the camera, and we can all see the extrusion and deposit processes of the filament. As you can see, the filament is already being fixed on the surface of the bed, on the glass, the first layer. This noise is just a wire which is touching it. Let's just place this way so that the wire do not move and do not touch the bed. We can use the clips we have and which are provided by the machine's manufacturer. There is no problem. There is no stack, block, or weird movement at all. It could damage the print. The machine, by using this file, is now one of the things this file contains is what we call a production of adherence, or raft, which is the throwaway portion of a print that essentially lays down a flat area on the print surface to help the adherence of the actual desired 3D model to our bed, and it does so precisely. It is not always needed though. If we calibrated the bed properly and we use any fixing element such as spray or varnish or a glue stick, a specialized glue stick, we do not need to make use of these rafts. Rafts, nevertheless, help very well the bed adhesion. They create strong foundations on which to build the upper layers. They help avoid some printing defects. That is the advantage number one. But they also have disadvantages. One disadvantage: it is a much slower process. If our model needs, for instance, 1 hour to be printed, by using raft we might need 20 more minutes. So our model will need 1 hour and 20 minutes to be done. This is one of their most important disadvantages: time length. The second disadvantage is the fact it is using more material. If we used raft in all our prints, we have to be aware we would be using a percentage of material which is useless, which serves just as an adhesion component. Do we recommend raft? If you are new in this, we do strongly recommend it. If you have experience with fixatives and you know how to calibrate beds, we only recommend rafts for objects with a very small surface area. We explain now what we mean by a small surface area. Imagine we would like to print a horse. If we printed a horse, obviously the horse legs, their hooves, are smaller than the horse itself. The surface of the hoof and its contact with the bed is so small it can get unstuck during the printing process at any time. To help those legs, those small hooves with their small surface area to detach, we should widen the adhesion area, and one of the things we can use is raft. It is not the only one though. We also have the possibility of using BRIM. We'll see later on. BRIM is a very similar device, but which uses less amount of plastic and is quicker. So there are prints where raft is perfect to use, but we don't need it always, and it costs us time and use of material. We can see the printing process is going almost perfect, both in its size and its thickness. Many finished models present a defect when the nozzle is so close to the bed. We did not calibrate it properly and we made it stand too close. This defect is called elephant's foot. The elephant's foot are like straight tubes that end in a shape like this. When the nozzle is too close to the bed, the plastic gets so smashed it produces this defect of elephant's foot. When we have our model completely finished and we take it out, we realize instead of having a straight base, let's think we would like to print a cube, the cube will have a wider lower part in comparison with the upper part of it, because the filament has been too smashed on the bed.